Well, hey there, kiddos. Today we're going to talk about changes to M and B. And if you'll remember, M is your slope when you're talking about a equation, and B is going to be your y-intercept. So we're going to talk about what happens whenever we change those two things in an equation and what it does to the graph of that equation. It would help if while we're doing this you have different colors. 2 or 3 different colors would be beneficial. If you don't, you're just going to have to label and help, and so that you can see. So number 1, they ask us to sketch a graph of the following equations on the same coordinate plane, and then we're going to look at them and see what happens. And so they've already graphed this y equals x for us. That's this line right here. By the way, if you do not remember, this is your parent function, and everything we do today we're going to compare to the parent function. So everything will get compared to y equals x, and this is what it looks like. It's an increasing line, passes through the origin that has a slope of 1. So we're going to graph this second equation, y2 equals 2x. So the first thing we need to know is the slope of this line is 2, because that's the number in front of x, and the y-intercept of this line is 0 because there is nothing. There's no plus or minus anything over here. So we're going to start at 0, and to get to our next point, since my slope is 2, that's the same thing as 2 over 1, so I'm going to go up 2 and over 1, and I can go backwards and go down 2 and left 1, and there are my points. And so then I'm going to connect them, and I'm going to make a line. Our straight edge would be helpful as you're doing this, but if you don't have a straight edge, that's okay. Just do your best to get the line drawn so that you can see what happens. So there's our line of y equals 2x. This is going to be the y equals 2x, and you see mine is not a different color, so I'm going to label it so I know that this is the 2x. If you don't have different colors, do the same thing. So now we're going to do y equals 5x. Same thing, we're going to have slope equals 5. And again, the y-intercept is still 0. So these all have the same y-intercept. They all start right here at 0. But now this one, my slope goes up 5 and over 1. So I'm going to go up 5, 2, 3, 4. It's way up here and over 1. And then when I go backwards, I go down 1, 2, 3, 4, 5, and over 1. And I'm going to connect those and make a line as well. Just like that. And again, because I'm using the line function on my graph and I'm not actually drawing them, I'm going to have to label it. That one's 5x. So I've got 5x, 2x, and this one right here is y equals x. And so the question is, just looking at the equation, how is the slope changing? Well, my slope went from 1 to 2 to 5, so my slope is increasing. It is getting larger. And so what happened when I increased the slope? How do each of those how does this line and this line compare to the original? Well, if you look, y equals 2x and y equals x, and it really helps if you just look at this first quadrant, because that really gives you a good visual of what's happening. If you compare y equals x and y equals 2x, y equals 2x is steeper. And then if you look at y equals 5x, it's even steeper. And so whenever I make the slope get bigger, I increase it from what it already was, it makes the line steeper. So how does each graph compare? They are steeper, because they have a larger slope, makes them increase at a faster rate. So let's do another little set. So we're going to now they didn't graph the parent function for us, we're going to have to graph it. Okay, it's got a y-intercept of 0 and a slope of 1. So up 1 and over 1. And then we can draw our line. I'm going to try drawing my lines with my actual pen and see if I can make pretty lines that we can compare. Maybe colors will work here. So this is going to be, that's our parent function, y equals x. Now I've got to do y equals 0.5x. Well, the slope of this line is 0.5, which is the same thing as 1/2. And I'm going to use 1/2 because it's easier to graph that than it is the 0.5. And my y-intercept for this line right here is still 0. So again, I'm not changing y-intercept here, I'm only changing the slope. So I'm going to change my color since I did the original one in purple, so I'm going to do this one in red. So it starts at 0, but now it goes up 1 and over 2. So I'm going to go up 1 and over 2, and I'll go backwards, down 1 and over 2. And when I connect those, here's my line. And so that's going to be my y2. That's the red one. And then we're going to do this 1/5 x. We'll do this one. We'll make it green. So the slope of this line is 1/5, and the y-intercept, sorry about that, Belle, I wasn't prepared for that. I'm recording in my classroom, obviously. So the y-intercept of this is 0. Again, we start at 0, but this time my slope goes up 1 and over 5. So I'm going to go up 1 and over 1, 2, 3, 4, 5. And then I can go backwards, down 1 and over 5. And I can connect my dots and make my line. And just like before, like we did in the last one, we're only going to compare what I'm going to say is true no matter where you're looking at on the graph, but the first quadrant right here on the coordinate plane, it makes it very plain to see. So part B, or this question, how is the slope changing? Well, I went from 1 to 1/2 to 1/5. So my slope now is decreasing. It's getting smaller. And when I made my slope decrease, my lines got less steep. The red line is less steep than their parent function, and the green line is even less steep than that. And so it just got less steep. So whenever I make the slope decrease, my lines get less steep. And I guess we could say more shallow, you could say less steep, however you want to word that so that it makes sense to you. Okay, so let's do the third one. Again, we're still changing slope. We're still looking at what's happening. I got to graph my parent function. Starts at 0, has a slope of 1. So here is my parent function. I didn't draw a very straight line that time. And then we're going to do y2. We're going to graph y2, and y2 just says negative x. Remember, that means there's a -1 in front, so that means my slope is -1 or -1 over 1, and my y-intercept is going to be 0. So we're going to look at what happens here. So I'm going to start. I made it it starts at 0, and I've got to go down 1 and over 1 for my slope. Or if I go backwards, it's up 1 and left 1. And so here is that line. I know that's really kind of ugly. So there is that line. So now let's do the third one. So y equals -2x. So this time my slope is -2. And my y-intercept is 0. So again, I'm going to start at 0, but I'm going to go down 2 and over 1. And then I can go up 2 and left 1, and I can connect those points and make a line. And so how is the slope changing? Now there's a couple ways to look at this. You can say in this problem that the slope is decreasing because it went from +1 to -1 to -2. But that's not what I really want you to look at. What really happened is that I went from a positive slope to a negative slope. So how is the slope changing? The signs changed, is what happened. They went from positive to negative. Because the negative does something different. It didn't necessarily make it any steeper. The red line right here, I have a -1 slope and I have a +1 slope. The 1 is what causes the rate of change. All the negative did was make my line decrease instead of increase. But this red line and this purple line have the same rate of change. They both are increasing or decreasing at the same rate. This one goes up 1 and over 1. This one goes down 1 and over 1. All the negative did was change the direction. And so how do these graphs compare to the linear parent function? They change direction. So instead of increasing, they are decreasing. So we can say that they change direction, and the word that you will see, the word that will show up when you answer questions like this, it will not say they change direction. It's going to say they are reflected. And so what happened is I took this purple line and I reflected it over the y-axis, and so when I reflected it over the y-axis, I reflected these points over, and so now my line it decreases instead of increases. So this is reflected over the y-axis, and that's what happened. But you're going to see that it's going to say it was reflected. Negatives make it reflect, makes it change direction. So now let's move to a new set of graphs. So now I'm going to sketch a graph of these equations, and then we're going to look at it and talk about what's happening. So the first one, parent function. Get your parent function drawn on there. You should be really good at that by now. We've done it like 3 or 4 times. So there's your parent function. Hopefully you draw straighter lines than I do. Now we're going to do the second one. I've got x plus 1, and so the slope of this line is 1 because that is just an x. and the y-intercept of this is 1. And so now my y-intercept has changed. Instead of all my y-intercepts being 0, this one has a new y-intercept. This one has to start at 1, and then my slope goes up 1 and over 1. And so they have the same slope, but their y-intercept changed. And so here is that one. That makes this line. And so hopefully you notice that those two lines are parallel to each other. They're not going to cross because the only thing I changed was the y-intercept. They have the same rate of change. This one goes up 1 over 1, and so does this one, up 1 and over 1. And so they have the same rate of change. That's what makes them parallel. But the y-intercept took it and it moved it up. Hopefully you see that. So now let's look at the next one. So we're going to do x minus 3. Well, the slope of this is still 1. But the y-intercept of this is going to be negative 3 because of that minus sign, which means this one starts down here, 1, 2, 3, and then it goes up 1 and over 1. And so here is that line. And hopefully you notice that that line is also parallel to the other two. That's because they all have the same slope. But it's moved down from the parent function because my y-intercept changed and became negative. So we're going to do one more. I'm hoping I have a color on here that will work. Yep, we'll do blue. So the slope of this one is still 1, but the y-intercept of this one is going to be 3.5, and I'm going to call it 3.5, but you can write 3 1/2. It's the same thing. So my slope now is at 3.5, so I'm going to go up 1, 2, 3.5 more. Now here's where you have to be careful when counting your slope, because you have to go up 1, which means you have to go up a whole space. If you only go up to this line right here, you've only gone a half. In order to go up 1, you have to be in the middle between the two. So I've got to go up 1 and over 1. Otherwise, you haven't gone up a full unit. You have to go up a unit. And so this is in the middle, so you have to still be in the middle after you do it. Same thing when you go backwards, go to the middle and back over. So connect those. And look, they're parallel again because their slopes are the same. But my y-intercepts are different. So right here, how is the slope changing? It isn't. The slope is staying the same every single time for these, and so that's what makes them all parallel. So how do they compare to the parent function? Okay, well, first of all, they're all parallel, but they are also all translated. The red one got translated up 1 unit, which is a word you learned, in junior high. Translated means slide. I took this line and I slid it up 1 unit. That's all I did. And then I took this line right here and I slid it up 3.5 units to make this one, and I slid it down 3 units to make this one. So they are all translated. And so changing the y-intercept translates my graph either up or down. We won't in this class translate right or left, but it will translate it up or down. And so what's the relationship between all the lines? Well, they are parallel, like I talked about all the way through. So let's do a summary. Slope affects the steepness of the line. The bigger the number, the steeper the line. The smaller the number, the more shallow the line. But the slope affects the steepness of the line. The y-intercept affects the starting point. Of the line. So it affects where it begins. Does it start at, excuse me, does it start at 0 or did it start at a different place? So the y-intercept affects the starting point. It will translate it up for a positive y-intercept, down for a negative y-intercept. So lines that have the same slope, just like we talked about several weeks ago, or a week or so ago, have to be parallel. And we didn't really talk about perpendicular lines, although we could. Perpendicular line slopes are opposite reciprocals. As we talked about that about a week ago as well. And if I multiplied the slopes of two perpendicular lines, remember their product is always -1. And we could have done a perpendicular line on here because over here, when these two reflected, right here, when the purple one and the red one, when I did this one and this one, their slopes are opposite reciprocals because the slope of this one is 1. Well, 1 and -1 are opposite reciprocals because they're both just over 1, so they change sign, and so they are definitely perpendicular lines. But that's what happens. So here's the thing you need to get. If I change the slope, it changes the steepness of my line. If I make the number bigger, it makes my line steeper. If I make the number smaller, it makes my line less steep. The y-intercept moves the graph up and down. It translated. So if I take the y-intercept and I make it bigger, it translates my graph up. If I make it smaller, it translates my graph down. The other thing, and the very big thing, is that a negative does not affect the steepness of the line. It's the number that will affect the steepness. The negative only reflects the line. So if I put a negative in front of an x in front of a slope, the negative reflects it. The number affects how steep it is. So that is changes to M and B. We'll practice this tomorrow or on Monday. I hope y'all have a good rest of your weekend.